Okay, thank you so much to Silvery. Let's see. So I will kick it off with a question, but if you have a question, you haven't been able to post it. Oh, great. So Indy Gupta, do you want me to ask on your behalf, or maybe we can promote you?
By the way, Amit, can you enable video? Disabled.
Good question. Or ask to start video.
Nice, thanks.
Okay, great. Okay, great. So you could ask, how does dSpace handle failure of devices? Yeah, so that's the first question. So how does dSpace handle device failure?
So this is a great question. If the physical device failed, then it's sort of orthogonal to the problem that dSpace addresses. We address at the software level, and if the physical device failed, then there are a lot of existing solutions for that, but it's not what dSpace can help address.
Okay, I'll follow up with another question. So, in the talk, you sort of you talked mostly about devices in the home and sort of applications for home devices. I'm wondering if dSpace is also appropriate for other kinds of IoT devices, like let's say in public spaces or spaces that have less hierarchical ownership, and if so, what kind of challenges might arise there?
Right. So a lot of these design principles we identify in dSpace, they are applicable. We believe they are applicable to other smart space scenarios, such as offices, buildings, or university campuses. For example, if university want to enforce some COVID policy at the campus level, and then this policy may be translated to, say, building level and then the room level. So this hierarchy, this idea of hierarchy appears naturally in different scenarios, and this is where dSpace can, its designs can help address.
Okay, and I believe Natalie has a question from Slack.
Yeah, so this question from Slack asks, with smart home devices with per device apps, the response times for any functionality changes are very low. In your experience, did using Kubernetes in the cloud give the desired response times, like when having to shift to emergency control, etc.?
Right, that's a good question. So our implementation based on Kubernetes allows us to deploy this dSpace in a flexible manner, where if you have latency sensitive ones, you can deploy these ones on-prem, whereas you have also the ones that you that's like privacy sensitive, you can always deploy it on-prem. And in our paper, we have evaluation on this, that we found the device actuation time still dominates the overall response latency. So we believe the overhead added by dSpace is minimum.
Okay, and then I'll ask Indy's second question, which is, did you perform any human user studies to understand how the non-power users might use Digius abstractions?
Right, so we do have a user study, but that's more developer focused. In that user study, we have some sort of end user front-end questions, and but to expand on that study to the very end user who have zero programming knowledge, it's our on our future work. So that's a great direction.
Okay, I have one final question, which is, I think I maybe missed this. Where do the dSpace programs sort of actually run? Which computers do they actually run on?
Right. Well, the answer is you can run it on. You can run the Digius. Each Digius are independent. You can run some on the cloud, some on the on-prem, on your own servers, and like For example, some popular IoT frameworks like Home Assistant allows you to run on Raspberry Pi, and that can happen for dSpace too, with like a lightweight Kubernetes distribution, yeah, like K3s, for example.
Yeah. Okay, with that, thank you very much, Silvery. Next up, we will have.
All right, cool.
Thank you, Charlie.
Hi, Silvery. Okay, before we start questions, let me quickly just introduce my co-chair. So Bingsheng is the co-chair for this session. So Bingsheng, hi Bingsheng. Bingsheng is
nice to meet you guys.
Hey, Bingsheng, do you want to quickly introduce yourself?
Hi, hello everyone. I'm Bingsheng. So I'm actually currently a faculty member in School of Computing, National University of Singapore. So I'm very glad to see you everyone here. Take care and keep safe.
All right, thanks, Bingsheng. All right, okay, so for the audience, if you want to ask any questions, there are two ways. Either you post your questions on Slack, we'll monitor the thread, or you can raise your hand and we will promote you to panelist. You can ask your question with your camera turned on. Okay, let me check if there's any questions. Okay, I guess so far I don't see any questions on Slack. I don't see any hands. So yeah, maybe I can just get the questions started, give other people a chance to think. So there's always this conflict between generality and functionality. So when you design this API, this programming interface, how do you balance between the two? So how do you design a general interface, but also doesn't sacrifice the kind of functionalities these devices actually want to have?
Very interesting question. So what is the functionality here? Say the functionality here is to use these devices to program for some application scenarios. Right? Let's use a more concrete example. You have a few lamps, actually the one we use in the presentation. You have a few lamps, you want to, simplest thing, you want to control the brightness of all lamps together. And what's the generality here? You want to allow your program to generalize to all kinds of devices. All kinds of lamps. So what dSpace provides is that, first of all, it allows you to create higher level abstractions that can control all devices together. So you have your functionality here. So what's the generality? Say you have lamps from different device vendors, and then each of these devices, they expose different programming APIs, allows you to configure the device via different commands. So dSpace allows you to create this sort of universal devices that abstract away this device heterogeneity, and then your high-level abstraction, like the room, can use these universal devices. And then your policies defined at the room level, they're generalized to all kinds of devices, so it's hidden away. There is one question, I think, from the audience this morning asking about, what if some of your lamps have color, the others doesn't have it? How do you if you abstract this away, then your room is not going to be able to use the color. So I think in my answer, I was saying, in such a case, you do want to expose this heterogeneity to the upper level. And now if you have a policy that says, I'm going to, based on some condition, I'm going to update the room's color, that policy is not going to generalize to lamps that doesn't have the color. But that's a sort of the necessary, it's something that we cannot really do, or anyone can, yeah. Sorry, there's a prolonged answer.
No, that's good, that's good. I was also wondering, so I think if you have a general API for these kind of devices, and then later someone needs some extra functionality that is not already provided, I presume you need to also change the API, but is that a problem for the other existing devices? Do we need to modify their code too?
Right. So for IoT, one of the pain points is that this device firmware gets updated all the time. And sometimes this firmware, I don't know, just like Tesla car, they update their firmware, you got a new feature to use. It happens for IoT devices as well. It is indeed a pain for, say, we envision dSpace developer is going to cope with this kind of physical level updates. But like in our implementation, there is these different sort of features for developers to check these updates. For example, devices, they have version numbers you can check, and they are maintained via Docker containers, for example. So all of these tools, they are mature and they are battle tested sort of in data center environment. And people use them to handle such device changes. Right? In data center context, will be your server machines, they get updated, and then your software gets like CI/CD, etc. Do I answer your question?
Yeah. Wonderful. All right, let me see if there are other things, other questions from the audience.
I think there are some participants raised their hands.
Oh, Howie, okay, let me go ahead.
Hi, Howie from NUS here. Could you elaborate a bit on how, how dSpace, or what about dSpace allows it to do certain things that the other frameworks that you looked at, for example, Home Assistant, cannot do?
Right.
Thank you.
Thanks. So we have a a table of comparison in the paper where we show that what are the scenarios we can easily implement it with dSpace, but none of the existing frameworks can easily support. So they either doesn't support it at all, or you need to move mountains to support it. For Home Assistant in particular, the one we found it very difficult is to support these high-level abstractions. So in Home Assistant, you can create these device groups, but that device group, you even need to extend their existing group API to handle different device types, and you need to sort of write code to sort of actuate different devices. Like they have this built-in like turn it on, turn it off API that you already use. But for others, you really need to build new extensions to do so. That's for one. And the other is this, in dSpace, we support this first-class composition, meaning in the runtime, you can compose devices easily, and the intent, the control, sort of control events that passing between between the high-level device and low-level ones, they have certain guarantees, like the intents never get missed, right? The low-level ones is always being surfaced to the upper-level ones. To support this kind of feature, we found it difficult in existing framework, including Home Assistant. We have some lines of code numbers in the paper. Feel free to check it out. But great question. Thanks.
Thank you.
All right, let's have one last question before we move on. So I think Jianyu, you raised your hand.
Yes. Hi, I'm Jianyu from Hong Kong U, and I have two questions. First, I since that you use Kubernetes to for all the services, I wonder how much is the boot up time for like the whole services. So if you have one new lamps or new robots that is connected to the house, will the boot up time really high, or do you measure this data, the boot up time? Yeah.
Do you want to ask your second question and I'll answer in particular?
Yeah, okay. The second question is so I wonder so how do you write the dSpace so if I want to develop the dSpace for a new lamp, do I need to write some kinds of wrappers, or do I need to rewrite the whole drivers or the whole things? Yeah, that's basically my two questions. Thank you.
Yeah, thank you, Jenny. So both are great questions. So the boot up time of Kubernetes and also these devices or digidata, we say they are not on the performance critical path. Right? What do we mean by performance critical path is that when someone or some physical events, whether it's human inputs or some sensor inputs that trigger some actions, those ones we care about the performance, and we have data in the paper. For this sort of device onboarding time, usually what happens is that people, well, today's user, they're going to spend a few hours to set up just one device. And I mean, dSpace does help address that in the sense that we provide these reusable modules, and maybe they are pre-configured when shipped to the users. But really, that's not sort of the kind of performance we we need to optimize too much. I think in the regard of the performance you are worrying about.
Of course. I just wondered, it's like if in the original system, it just put up like in 30 seconds, and in this system, you need to have to wait for 10 minutes, then that would make a huge difference. That's what I mean.
Right. I believe our implementation doesn't sort of make the this one time put up and too bad. And then quickly to your second question, since we're running out of time. So how do we write a new sort of land? Do we add the repro? There are existing sort of third-party device libraries that one can use to interact with the physical devices. And indeed, that's how we implement the example devices we include in the paper. And usually that takes some lines of code to integrate with it. But nice thing here is that once you have done on the leaf, on the leaf devices, the upper level ones can simply reuse them.
Okay.
So you don't need to do this again.
Okay, that makes sense. Thanks a lot.
Thank you.
Thank you.
All right, let's thank Silvery for his talk and questions and from all the audience. So you can stay here so that we can have the panel discussion at the end of the session.
Sounds good. Thanks, Xiaoling.
All right, thank you. Next up, we will have